Today we're going to be talking about the LCM, or the least common multiple. Now first let's go ahead and talk about a few terms. The first term we need to talk about is a multiple, because if we're going to be talking about least common multiples, we're going to have to know what a multiple is in the first place. So a multiple is a product of that number and a whole number. So what does that mean? Basically, an example of this would be if you're saying a multiple of 4 is 20 because 4 times 5 gives you 20. So basically, if you're going to list the multiples, which you can do in this lesson, the list of multiples for 4, we would be listing 4, 8, 12, 16, 20, because 4 times 1 gives you 4, 4 times 2 gives you 8, 4 times 3 gives you 12, and so on. So basically when we're talking about multiples, we're listing our multiplication facts. So now let's go ahead and talk about a least common multiple. So if we know what a multiple is, a least common multiple is basically if you're comparing the multiples of more than one number, you're looking at the smallest multiple they both have in common. So the least common multiple is also called the LCM, and make sure to write in your notes, it's the smallest multiple of two or more numbers that they have in common. So, for example, if you're going to find the least common multiple between 2 and 3, you would first have to list out your multiples. So 2, you'd have 2, 4, 6, 8, 10, 12. And then listing the multiples for 3, 3, 6, 9, 12. But I don't have to go that much further because I have a 6 in common. But I also have a 12 in common. So you got to be really careful that you're looking at the smallest number possible. So you don't want to have to go out any farther than you have to. So in this case, we have 6 is the smallest number they both have in common. Okay, now another term you need to know is the least common denominator. It sounds a lot like least common multiple, and it has very similar little initials here, the LCD instead of the LCM. Now this is basically the least common multiple of two or more denominators. So if you're comparing more than one fraction or trying to get the fractions, the denominators the same, you'll be looking for the smallest number they both have in common. Okay, so that's what we're going to be doing here today. So let's go ahead and do a few more examples. Let's go ahead and look at example number 1. This first example, we're going to be finding the least common multiple of the numbers 10 and 14. So the first step we're going to do is just like we did the greatest common factor, how we did the prime factorization, we're also going to be using the prime factorization or the factor tree, except we're going to be using it a little bit different this time. So let's go ahead and find the prime factorization of 10 and 14. So first let's go ahead and break down 10. 10 is 2 times 5, and both of those numbers are prime, so that is my prime factorization, 2 times 5 for this number. And then let's go ahead and find the prime factorization of 14. We break it down to 2 times 7, so those two numbers are also both prime, so we don't have to break it down anymore. And we have 2 times 7. So now here's how this is going to work. First of all, we got to figure out what numbers do we have represented in both of these numbers. So we have a 2, a 5, a 2, and a 7. So we don't want to repeat our 2. We're just going to only say it one time. So we have a 2, a 5, and a 7. So basically we're going to multiply those together, and that is going to give us our least common multiple. So we do 2 times 5 times 7. Alright, so our least common multiple of 10 and 14 would be 2 times 5 times 7. Now if you do 2 times 5, you're going to get 10, times 7 is going to give you 70. So the least common multiple between these two numbers, so the smallest number that they both have in common, is 70. Alright, let's go ahead and move on. Alright, let's go ahead and find the least common multiple of these two terms. Now we have variables involved here, but don't get freaked out. We're going to do the same process. We're just using the variables as well, because you remember when we broke down numbers with variables, those were just added on to the end. So it would be 5 times x is the prime factorization of this term. So let's go ahead and break it down. So just like I said, it was 5 times x, because 5 is prime, and then we broke apart this x into two x's. And then let's go ahead and break down this one. 12 can be broken down into 2 times 6. 6 can be broken down more into 2 times 3. So now the prime factorization of this term is 2 times 3 times y. Times y. Alright, so let's go ahead and see all of the terms we have in common. or that we have represented in both of these numbers. We have a 5 represented, we have 2 x's represented, we have 2 2's represented, we have a 3, and we have 2 y's represented. So basically, we are going to go ahead and just multiply these two terms together. So if we'd have 12 times 5, which would give us 60, and then we have x squared, y squared. So basically, if you multiplied 5 times 2 times 2 times 3, you'd get 60, and then x times x gives you x squared, y times y gives you y squared. Now, one thing to remember, if you notice up here, I circled 1 2 here, but not the other 2. Now, you got to think about what's different between these two scenarios. In this case, 2's are represented in both of these numbers. But in this case, 2 is both represented in this one number. So it's not just a 2 here, it is a 4, because 2 times 2 gives you 4. So that is why we're still keeping it together here. I know it gets a little bit confusing, but the more that we practice this, the more we'll get a little more proficient on it. Okay, for example number 3, this time we are going to find the least common denominator. So, when you hear least common denominator, it means we're dealing with the bottom numbers. So we're going to be dealing with a 5 here and an 8. So, let's go ahead and break them down so that we can find the smallest number they both have in common. Now, 5 is just 5 and 1, so we can't break it down anymore because it's prime. Now, 8 we can break down into 2 times 4 and then 2 times 2. So basically we have 2 times 2 times 2. So, we got to compare the two prime factorizations. So there's no 5's over here and there's no 2's over here. So we're going to multiply it all together. So since they have nothing both in common, we're going to multiply it. So we have a 5 times 2 times 2 times 2, which is going to be 5 times 8, which gives you 40. So 40 would be the least common denominator. Now, when you would use this is if you wanted to compare these two fractions or if you wanted to add them or subtract them, that is using the least common denominator, the method. So let's go ahead and use it now for these two fractions. We're going to go ahead and compare 5/7 and 7/9. So in order to do that, we're going to find the least common denominator. So we're only dealing with the bottom numbers here at first. So let's go ahead and break down those two numbers. We'll have 7, and then we're going to have 3 times 3. So we're going to multiply all together, and our least common denominator is going to be 63. So that means we're going to have to work to get both of these fractions with the 63 in the denominator. Now, remember how I told you this before? Like if you're comparing fractions, you have to have them cut up into the same amount of pieces so that you can compare the top numbers. Because as of now, these are completely different size pieces. So if you're cutting one whole into 7 pieces, the pieces are going to be bigger than if you cut one whole into 9 pieces. So we want to be able to compare it evenly by cutting it up equally. So now let's go ahead and figure out, how did I get this denominator equal to 63? And that was because I multiplied 7 times 9. So that means I also have to do the same in the numerator, because in order to keep our fractions equal, we have to do the same thing to the top that we do to the bottom. So if I multiply 9 here, I have to multiply 9 here. So we have 45. And then we're going to go ahead and multiply over here by 7, because I did 9 times 7, which gives me 63. So now I'm going to do 7 times 7. It's going to give me 49. So now this is a lot easier to compare. We're just saying, is 45 or 49 bigger? Which one? So since 49 is bigger, we have the less than symbol here. So this would be our final answer. Alright, as always, make sure you have the complete notes on the front of the board, the complete notes on the back of the board, and make sure that you have your practice problems done. So let's go ahead and look at those real quick.
Okay, you have 4 problems to do for me. The first 2 problems, go ahead and find the least common multiple. So you're going to break them down with a factor tree and then find the multiple from there. Numbers 3 and 4, you're going to compare the 2 fractions, but in order to compare them, I must see your work, and I need to see that you get the denominators equal to each other. So find the least common denominator and then change the numerators accordingly and go ahead and figure out which one's greater than, less than, or equal to. Alright, good luck. We'll see what you get tomorrow.